Hi, in this video I'm going to be showing you how to sort of create a simple wavetable type synth. For the first part I'm going to go sort of fairly quickly because it replicates information which is in previous videos. In particular, if you look at the simple sine synth demonstration, that'll help you a lot. So for the purpose of this demonstration, we are going to want to receive MIDI input. So I use the MIDI in, and then I shall connect that to X note in. I shall connect that to X note in, and we shall then use a number box to display the note received, and we shall use a number box to receive the velocity. So if I stretch that, and then so note on, note off, we shall put that into there. So let's make this all this bit smaller because it's not the main bit we're interested in. So if I start this and I press a note on here, it just let me turn some of this stuff off. So if I press a note, it will cause this to press the note number. I've got a MIDI keyboard connected to this, so I'm now pressing note number 36 even, and you'll see that a number 1 comes up when I press it, and when I've released, it sends a note off. So if we want to send this to a sine wave, we would need the MTOF, which is it basically converts a MIDI note number to a frequency, so we can use that to start generating an audio file. So, and then we might use something like cycle. That's a message going on. It's all going wrong today. So cycle, which will sort of generate a tone starting at that frequency, and we've got EZ DAC down here. If we have a multiply object, so multiply two signals, it will give us a basic sort of turning on and off of the audio system. So if I connect this through, do sort of like this. So now, so this is a simple sine wave oscillator. It receives MIDI information in, which is put into there. So we've got the note number 48, which is converted into a frequency, and then we've got an R number 1. If it's multiplied by this stream, lets the audio through. When it becomes a naught, it mutes it. So we could make a lot more better version of this by using an ADSR, but we're going to stay with that for the moment. Cycle already has actually defaulted, has it's like its own sort of wavetable that it reads from to generate our cosine value, and we can overwrite that by creating a buffer. So if we do a buffer object, there we go, and we'll call this buffer, we'll call this WT. So instead of getting the cycle, if we do WT here, or we'll do a set, what this will do is it will now when I've done set, so we'll do a message, let's go set WT. So what this does is it overwrites the sine wave with the current contents of this buffer. We'll make this buffer 11.7 milliseconds in duration. So now if I set this, our we're not actually hearing any audio because what's actually stored in our buffer object is actually sort of silence. So we need some way of actually writing in information to that. So an easy way of doing this is through the waveform. So if I have a new object and this is waveform, it brings up a box that looks like that. So we need to sort of tell this that we want to look at the waveform described by WT. So this buffer object is called WT, and it contains a sort of audio waveform which we are using here, and we're also going to use it on here as well. So the second thing I do is we need to do another object which does mode draw. Then this mode draw allows us to actually draw in audio. So if I click on mode draw, when I go hover above the waveform, it now allows me to actually draw in a waveform. So so this is altering what's in this audio buffer up here, and to prove that, if we double click on that, we see that we've got the same sort of waveform there, which is WT. So now, because cycle is picking up waveform, that means that it should be playing this. So if I turn the audio on and press a key, it changes. It plays a cycles around this waveform. So I could make sort of very different sort of changes to this. The main thing to notice with this is if we make any changes within this waveform window, they're not necessarily reflected in this cycle object until we reset it again. So now it's changed. Make something very spiky, and then if we set W, it gives us a slightly different sort of sound from that. So another way of automating that is if we connect this connector to set W. What will happen is whenever you've changed something there, that will cause this to be reset. So if we make some changes. So make some changes there, they're automatically reflected when receive this waveform there. So really the only thing sort of left to do with here, if we've got a waveform that we actually want to actually use again, we could do write and save. So if we put another couple of messages in here, this write message causes the current contents of our buffer to actually be saved as an audio file. So for example, if I write this, and we'll call it a file, so we'll have TW, we'll call that, and then save that. So now if I change this and I wanted to reload that maybe later on, if we use the message replace, and what replace does is it puts up a dialog box which allows you to upload a new WAV file into the buffer object. So if I click on replace and then find the file that I originally did, open it there, it automatically updates on that. So that's how we can adapt our sine wave synth to be a simple wavetable.